Hello everyone. In this lecture number 2 we discuss the components of GIS. As I told you earlier, like any other information system, GIS also have set of components. Those components work independently so that GIS runs smoothly. So let's start with this topic. A GIS provides you all the tools needed to solve spatial problems. So every type of techniques or tools are available in GIS that will help you to solve different types of spatial problems. A GIS is basically made up of 5 components. So within a larger system, those 5 components work independently and also they interact with each other so that the complete GIS system runs smoothly. So these are the 5 components are there: hardware, software, data, people or user, and the few set of methods or workflows we can say. Those are the 5 essential components are available in GIS. Each component contributes to the overall system that enables you to make the smarter decisions. So every component has impact in complete GIS system. Every components contribute their part so that GIS run properly. So one by one in this lecture we'll discuss all these components in front of you. So first one is their hardware. Hardware means in simply we need a computer. That may be the desktop computer, maybe the laptop computer, or even nowadays in tab or in smartphone you can use GIS. Or in case of organization, in case of large organization, we may also need server computer like mainframe computer where multiple users will simultaneously use GIS. So ultimately whatever the types of computer, we need computer as a hardware. So hardware are the technical equipments needed to run any GIS software. So it's a very simple thing. If you do not have any computer, how can you install and run GIS software? So of any type of computer you need for run GIS software. That includes centralized computer server like mainframe computer, which can handle simultaneously multiple users requests in an organization, or we may need desktop or laptop computer, or maybe handheld computer like smartphone, tab that we can also use. And those sort of computer must have enough processing power. High speed computer processor is required and large capacity memory is needed to store huge amount of geographical data. Here I should mention one point that generally unlike other data, geographical data are bulky, voluminous. Its size is generally large size. So for that reason, to handle those data, to store those data, to process those data faster way, we need such type of computer which have high processing speed and large memory capacity and large storage device. Then in GIS we also need some sort of special input output devices that generally we do not need in our in a typical use of computer, such as we need scanner, such type of one input device to scan the paper map or to scan the any paper data so that we can get the digital data. So we know scanner is a one type of input device which scan the paper documents and provide us the digital document. So the same like scanner, we also need digitizer. This is also a special input device that will where in this type of digitizer table, in this type of special hardware device, we can digitize or trace the paper map and store the digital map data on the computer. Although this digitizer nowadays are not used very frequently, it's a old technique used earlier, but whatever, that is another type of special input device is there. Then we need plotter and printer. You know the difference between plotter and printer, both are output device, but in case of printer, maximum we can print A4 or A3 size paper map. But if I want to take printout of a A0 size map, or if you want to prepare A1 size map, I mean the example in your house or in school, college, you already saw the paper map. Their size is large compared to your notebook. Okay, so if you want to take such type of large size printout, we need the plotter. For small size printer paper printout like A4 or A3, we generally use printer. So not only computer, in organization we have to also use some sort of special input output device. Example of input device, scanner and digitizer. Example of output devices are printer and plotter. The ability to create, share and use geographical data is enabled by these hardware devices, because ultimately those computer and those special input output device will help you to create, share your geographical data from one computer to another, and you can properly use your geographical data based on this hardware. And if you do not have hardware, then you can't use any sort of GIS software. Okay, so that is the one first component. Then second component appears software. As I told you in the previous lecture that you can't prepare GIS on a paper. We need computer, we need hardware, and the same way we need some sort of software that will perform data processing on behalf of you. GIS software provides the functions and tools needed to store, process, analyze and display geographical data. Ultimately, based on computer, everything will perform software, not manually. So data storing, data creation, data processing, data analysis and data display, everything we have to perform using GIS software. And in general, not only GIS software, every software provide you the program and the graphical user interface. I'm sure most of you already use some sort of software in computer, or almost all of you. So whenever you will use any software, there are menu bar is there, toolbar is there, status bar, working area is there. So this is called the graphical user interface of the software, which will help user to use this particular software. So every software provide you such type of program and the graphical user interface. Now here we can classify GIS software as per their size. So according to this, one type of GIS software is there which is called desktop GIS software. software which is only possible to use in desktop or laptop computer, or laptop, not only desktop. Some sort of GIS software is also available which is only possible to install in a centralized server computer. Server computer generally not found in your own house or in a small organization. Generally in a large GIS organization, they have this sophisticated high price centralized server computer. So some sort of GIS softwares are there that are possible to install on those type of centralized server computer, and the benefit is that if you install this GIS software in a server computer, all the employee of your organization, they can use this single software using their own personal computer, desktop, laptop, or even using smartphone. They can, through network, they can connect with this centralized server computer and they can use this GIS software. So organization don't need to purchase different software copy. Only one server GIS software they can purchase, and that can be used by used by multiple all the employee of this organization. Then come mobile GIS software. As the name suggests you, those sort of software you can use in a small processing power computer like smartphone, like in a personal digital assistant portable computer, or even even in different types of survey instruments. You can also use such type of mobile GIS software. Okay, so as per the computer size, we can classify GIS software: desktop GIS software, server GIS software, and mobile GIS software. Or in other way, we can also classify GIS software, that is, we can classify GIS software based on either this is a proprietary or commercial GIS software, or open source GIS software, free and open source. Commercial and proprietary GIS software, their license you have to buy. It's not free. They do not provide you the source code of the program. They only provide you the license of this software once you buy it. But another type of GIS software are also available, which is free and open source. That means you don't need to buy any license copy directly from internet. Free, you can free of cost, you can download it, you can install it in your computer. There should not be any legal barrier. But if you use proprietary or commercial software, then you know the terminology, pirated software. But in case of free and open source software, not only you can download freely this software, you can also get entire software source code. So if you have a programming background, in case of free and open source software, you can also change the program. So those sort of liberty also you have in case of free and open source software. And another one is there, proprietary or commercial GIS software. Okay, then come another important thing is that I have a computer, I have a GIS software, but I do not have any data. So in GIS, we can collect GIS data from different sources, and all such type of sources you can use for collecting GIS data. So here I just show you briefly all such type of GIS data sources. If you have any paper or digital map, or if you have any analog or digital map, that means if you have a cadastral map, if you have a topo sheet, if you have a thematic map, topographic map either in paper form, analog form, or in digital form for any particular area that you can use as a GIS data. If you have a aerial photographs, some photographs that was captured from the aerial platform, like helicopter, like aeroplane, like from some unmanned aerial vehicles like drone. So, those sort of photographs you can, they also contain geographical data. If you collect photograph from helicopter, if you collect the photograph of space from helicopter, this photograph contain lot of different types of geographical data. So the same way you can use also satellite images, where we capture the photograph of the earth directly from the satellite through some sensor. So those sort of satellite or satellite image you can use as a GIS data. We can also use census data, because as you know, census data contain different types of socio-economical information. So those socio-economical information are very good asset for attribute data. So those sort of data you can use. And next one is there, final one is there, you can also use survey data. That means as a surveyor, as a field worker, you can directly visit the ground, and from the ground with the help of survey instruments you can also collect geographical data. For example, different types of survey instruments are there. As you know, in your smartphone GPS is there. Your smartphone is GPS enabled, which is called global positioning system. This is another technology. Uh, I, I can't discuss elaborately this technology, whatever. So GPS receiver is a one type of survey instruments, or or different types of survey instrument like theodolites, total station. Those sort of survey instruments you can use, and directly from ground you can collect geographical data. And lastly, although I do not mention, nowadays internet is a one source of geographical data. Different types of geographical data nowadays are available on the internet, either free or you can buy directly from internet. So these are the different types of GIS data sources are there. Then we know we need the people either who develop GIS, or we need such type of people who will use it, will take the benefit of this GIS system. So people use GIS software to perform tasks on GIS data. Might include GIS administrator, GIS analyst, GIS cartographer, field worker. So in a GIS organization, different types of GIS users are there. According to their name, they perform different types of tasks. I mean, based on their contribution, GIS system develop in every organization. A GIS provides little value without a user to manage the system and develop plans to apply GIS to the real world problem. So once you develop any GIS, somebody should somebody should use it. And so for that reason we need the end user. Like somebody developed Google Map, but every day everyone using this Google Map as a user without knowing GIS or anything. So there is a developer part, there is a common end user part. So all are we can consider as a GIS user. And the last one is their last component is their workflow or methods. A GIS has workflows composed of unique structured, planned and business rule. So workflow or methods will vary organization to organization. Different organization have different business rule, different structured plan. So according to this, different organization follow different workflow or different methodologies. Organization develop workflows to improve efficiency by defining procedure and repeatable tasks. So for or in other way we can say organization develop different types of workflow to increase the productivity and maintain the quality. For repeatable task, same task perform again and again. GIS organization use lot of different workflow so that they can maintain, they can improve the efficiency. Now different types of methods or procedures are there in workflows. Some of them I just present here. How to store, manage and retrieve GIS data. That means in GIS different types of storage methods are there. Different types of data management methods are there. Data retrieval methods are there. But organization will choose which type of storing, manage and retrieval method. That is their business rule, that is their strategy. How to transform, analyze and present GIS data. So different way we can perform data transformation analysis. And organization to organization they choose proper way, proper methodology. So in this case, the right methods are key for successful implementation of GIS project. As different methodologies are there for data storing, data analysis, within organization have to choose right method. If they do not choose right method, their GIS project will be lengthy, time consuming, production rate will decrease, and maybe they do not provide the quality output. So that will basically create a unsuccessful GIS. So for that reason, right method once organization choose, it will create a successful GIS project, or they will successfully implement GIS project. So this is part is their workflow. Okay, that's regarding the components of GIS: hardware, software, data, people and user, and last one is their workflows. Thank you.